Hello, this is Britt Caswell with another example video. In this video, I'm covering example 1 from section 2-6 in the SavvasRealize Algebra2 textbook. In this video, we are learning how to solve quadratic equations. So the main focus of this is actually to be covering solving quadratic equations using the quadratic formula, which is written right here. Now the quadratic formula is nice because it is it will work with any form of quadratic. Alright, so sometimes factoring doesn't work, graphing rarely works, sometimes completing the square could be really ugly. So the quadratic formula isn't bad once you get used to using it, and it works for every single one. So it's kind of a go-to, like, fix everything kind of thing. So the first thing that you need to know with the quadratic formula is that your equation needs to be written in standard form equal to 0. So then what I'm going to do is identify my a, b, and c values. So here my a value is 3. My b value is the number in front of x, so my b here is -4. And then my c value is my constant, which is -9. Now everything that I've written in this equation that's written in black, that's always going to be the same. So I'm just going to go ahead and create what I call my little template, which is where I write all the stuff in black and leave spaces for me to put my numbers. Now it's important that when you're doing this, that you fill in the blanks with parentheses. Okay, because something like -3 squared, that's not the same thing as -3 squared. Okay, so just be aware that those parentheses are important, or else you're going to get messed up. Alrighty, so now I'm filling in my a, b's, and c's. So my a goes right after the 4 and right after the 2. Started writing the letter A instead of the number 3. So there we go. My b value, that comes here in the front. This is -4, -4. And my c value comes right here in the rear with a -9. Okay. Now when I deal with the quadratic formula, I actually take this part with the square root and I pull it out and solve it on the side. And the reason why is I'm really lazy and I don't like having to rewrite all of the formula over and over and over again. So that's why I'm taking it here to the side. So -4 squared is 16. And then 4 times 3 is 12. Times 9 is 108. And I have 2 negatives, so this is going to be a positive 108. So I'm going to add 16 to the 108 and I get 124. And so when I'm at this point, what I need to do is I need to do a factor tree so that I can kind of break apart this number and simplify my radical. So 124, I know that's divisible by 4. In fact, it's 4 times 31. And 31's prime, so I'm circling it. And 4 is 2 and 2. So what I can do is I can write the square root of 124 as the square root of 2 times 2 times 31. And here I have a pair of 2's, so they can come outside of the radical. And so there's my radical, okay? I'm just going to write that right here, 2 root 31. So back into my equation, I have x equals negative 4 is going to be a positive 4. And here in the bottom, 2 times 3 is 6. But I see that I have a 4 and I see that I have a 2. So I'm going to leave this separate as 2 times 3 because I'm going to be canceling out the 2 with the 2's up here. Okay. Now you could multiply that to 6 and still cancel things out. I think it's just a little easier to see here. So this expression turns into 2 plus or minus the square root of 31 over 3. So that's my answer. Now just be aware, sometimes different books might break this into 2 expressions. So they could also say x equals 2/3 plus or minus, they might say 1/3 square root of 31. That's the same thing, but it looks a little different, okay? These are both equivalent. It just depends on, you know, where you're getting the problem from or how you're doing the problem. All right. Man, there's lots of examples on this. I'm sorry for the long video, y'all. Let's go ahead and we're going to create our little template. Now the quadratic formula, it can be sang to the tune of Pop Goes the Weasel. And so that's really nice because it helps you to remember what values go where. So remember, these first 2 slots are your b value, right? So my b is -9. These 2 slots are your a values. So here my a value is 1. And then my last spot, that's where my c goes, which is 27. So remember, we're going to want to simplify -9, it turns to a +9. And 2 times 1 is 2. So then we just need the stuff from the radical. So all this stuff. So here, the square root of -9 squared is 81. And then 4 times 1 is 4 times 27. Just making sure I'm not lying to you, is 108. So 81 minus 108 is -27. Now remember, if you have a negative under the radical, we're going to pull that outside of the radical with the letter I. Alright, so then we need to break apart the 27. Well, I know that that's 3 times 9, and 9 is 3 times 3. So the square root of 27 is 3 times 3 times 3. You take out a pair, move it to the front. So when I combine that with my I, people usually write it like this, 3i root 3. Or you could call it 3 root 3i. Just make sure it's very clear that the I is not a part of that radical, okay? Now 2 can't go into 9 or 3, so this is our final answer. Alright, another one. So as you can see, the process for simplification, it's pretty much the same thing every single time. That little end part there with the factor tree can sometimes be a little different, but it's really not too bad. Alright, so our first 2 blanks is the b value, which is 6. our second two blanks is the a value, which is 2. And our last blank is our c value, which is 3. Alright, to start simplifying things, let's go ahead and let's do the radical part. So right here. Now this radical has some kind of interesting features. It's called the discriminant, the stuff that's underneath it. And so the discriminant tells us how many values to expect as our answer. So for example, here I got a negative 27 for my discriminant. That's how I knew I would have two imaginary answers. So here we go, 6 squared is 36. 4 times 2 is 8, times 3 is 24. So with our discriminant talk, right, here I have a positive discriminant. So that means that I'm going to have two real value solutions. So with 12, that's the same thing as 4 times 3. And 4 is 2 times 2. So I'm breaking 12 down into 2 times 2 times 3. I'm going to take that pair and move it to the front. So that one was a fairly straightforward expression. Now remember, we're going to take that number, that 2 root 3 that we got, and we'll be putting it into our equation because now it's the easier work. Alrighty, so then here I have a negative 6, so I can just drop the parentheses. And here I can multiply to make it 4. But do you see how I have two even numbers here? So I'm just going to be using that 2. So I'm just going to leave it as 2 times 2 because I can then just cancel stuff out. Now remember, when you do cancel out the 2 in the bottom, you have to cancel out from both terms here because this plus or minus is separating the terms. If you don't do it from both of them, you're messing up your problem, okay? You won't have an even problem. So here I have negative 3 plus or minus the square root of 3 all over 2. Alrighty, and just one more just for the heck of it, because why not? So I set up my formula. Now I was talking about that discriminant that goes under the radical here, right? And we said that when you have a positive one, you have two real solutions. If you have a negative one, you have two imaginary solutions. If your discriminant is a 0, that's going to tell you that there's only one real solution. It means that your parabola goes down and touches it, just like touches the x-axis once, and then swoops away. Alright, so here's our b values. So my b here is negative 2. We fill in our a values. My a is 3. And I fill in my c value. That's a positive 7. So we take all this good stuff, bring it to the side. So negative 2 squared is 4. Oh, I'm sorry, that should say minus 4ac. Ooh. I was talking about positives and negatives and almost made a big goof, didn't I? Alright, so now 4 times 3 is 12, times 7, I want to make sure is 84. Okay, it is 84. Okay, so 4 minus 84 is negative 80. So this tells me we're going to have an imaginary solution. So I know I'm going to have an I outside the radical. So now we're going to decompose that 80, right? I know that if I have 4 $20 bills, I have $80. So 4 decomposes into 2 times 2. And 20 is 4 times 5, so then we can break apart this 4 as well. So the square root of 80 is the same thing as 2 times 2 times 2 times 2 times 5. So I have two pairs of 2's that can come out. So this gives me a 4 and a 5, and then I also have an I. So I'm probably just going to rearrange this when I write it out as 4I root 5. Or you could call it 4 root 5 and then make sure that the I is out of there. However you really want to for the most part. So I have negative 2 is a positive 2. And I see both of these are even, so I'm just going to keep this as 2 times 3 so that I can cross out easier. Alright, so the 2 cancels out with this 2, leaving it as a 1. And 2 times 2 makes 4. Now it's really important when you cross this stuff out, if the 2 is being multiplied by something, it's okay just leaving that. But here where I canceled out the 2, see how I wrote in a 1? Don't leave it as a 0 or else that's not true, right? Because 2 divided by 2 is 1. That's a really common mistake kids make, is they'll just completely cross that out and not replace it with a number. Here we go. So I know it's a long video, but there are 4 examples of how to use the quadratic formula. Until next time.